Hey guys, today we're going to check our geometric sequences practice. So for the first section it says determine whether each of the following sequences is arithmetic, geometric, or neither. If you take a look at number 1, I notice there's an addition pattern. -4 plus 5 is 1, 1 plus 5 is 6, 6 plus 5 is 11. So remember, if there's an adding or subtracting pattern, that is an arithmetic sequence. Take a look at number 2. Well, 2 plus 6 is 8, but 8 plus 6 is not 32. But I do notice that 2 times 4 is 8, 8 times 4 is 32, and 32 times 4 is 128. So since there's a multiplying pattern, that's going to be a geometric sequence. Take a look at number 3. I'm not real sure about this, so I know that 1.5 plus 3 is 4.5, but 4.5 plus 3 is not 13.5. So I'm going to check for a multiplying pattern. And I'm, again, not sure about that, so I'm just going to divide. 4.5 divided by 1.5 gives me 3. 13.5 divided by 4.5 again gives me 3. So I'm multiplying by 3, it looks like. But when I do 40.5 divided by 13.5, I get like 2.97 da 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 da. So since the pattern changes, that is neither an arithmetic nor a geometric sequence. Look at the next section. It says for each of the following geometric sequences, find the common ratio. Then write the explicit formula for the sequence. So let's look at number 4. So I noticed that they multiply by 2. 10 times 2 is 20, 20 times 2 is 40, and so forth. So my common ratio is 2. Now my explicit formula, the overall, like the general explicit formula, is a sub n equals the first term times the common ratio to the n minus 1 power. So now let's plug in what we need. We're going to say a sub n equals the first term, which is 10, times my common ratio, which is 2 to the n minus 1 power. So that is my explicit formula. Let's go on to number 5. I notice if I do -7 divided by 7, I get -1. 7 divided by -7 is -1. -7 divided by 7 is -1, so my common ratio is -1. Now let's write our explicit formula. Again, I always start with the general formula. So a sub n equals my first term, which is 7, times my common ratio, which is a -1, so I'm going to put that in parentheses, raised to the n minus 1 power. So that is your explicit formula. Take a look at number 6. Now it looks to me like I'm multiplying by -4. And if you're not sure, remember you can divide. -12 divided by 3 is -4. 48 divided by -12 is -4. -192 divided by 48 is -4. So my common ratio is -4. And let's write that formula. A sub n equals my first term, which is 3, times my common ratio, which is a -4. Again, usually I put those in parentheses, raised to the n minus 1 power. Now let's take a look at the next section. It says for each of the following geometric sequences, find the common ratio. Then write the recursive formula for the sequence. So if I take a look at number 7, I notice if I do 108 divided by 162, I get 0.6666666. 72 divided by 108 is again 0.66666. So you could have either written this as your common ratio, or I know that that is 2/3. 2 divided by 3. That's just one that I have memorized. So now I'm going to write my recursive formula. I personally like to use the fractions. But remember, fractions and decimals are the same thing. Just be prepared for either one. So the general recursive formula says to find the next term, a sub n, equals your ratio times the last term. And you always identify the first term. So a sub 1 equals your first term. So a sub n equals, my common ratio is 2/3 times a in sub n minus 1, and my first term is 162. Now let's look at 8. So I notice if I do 50 divided by 100, I get 0.5. 25 divided by 50 is 0.5. So your common ratio is 0.5, or I know that 0.5 as a fraction is 1/2. Okay? So my recursive formula is going to be a sub n equals 1/2 times a sub n minus 1, which just means the last term, and a sub 1 equals 100. So now let's look at the last four. Number 9, what is the 14th term in this geometric sequence? 3, 9, 27, 81. I personally like to write my explicit formula and then use it. You can absolutely continue the pattern, that's just not what I do. So the explicit formula for this is going to be your first term times, I notice they're multiplying by 3 to the n minus 1 power. So to find the 14th term, I'm going to say 3 times 3 to the n minus 1. 14 minus 1 is going to be 13. And then I'm going to plug that in the calculator. So I'm going to get 3 times 3 raised to the 13th power. And you get 4782. I'll read it properly in a minute. 4782 969. So that's 9,782,969. That is your, oh, that should go up here. That is your 14th term in this geometric sequence. Now let's look at number 10. Number 10 says, what is the 11th term of this geometric sequence? So again, my personal strategy is to write my formula. My first term is -2 times, let's see, 10 divided by -2 is -5. -50 divided by 10 is -5. So my rate, or my common ratio, is -5 to the n minus 1. Well, to find the 11th term, I'm going to do -2 times -5 to the n minus 1. 11 minus 1 is going to be 10. So -2 times -5 raised to the, I want to say it was the 10th power. We'll see if that's right. Yes. And so my answer for that is going to be, and actually I want to show you something, guys. If I'm going to raise a negative to a power, I like to put it in parentheses. Raised to the 10th power, just to make sure. And what I was thinking is right. So be careful. If you're raising a negative number to a power, put that negative number, it's called the base, in parentheses. So -19, 531, -19, 531, 250. So the 11th term in this sequence is -19,531,250. Now let's take a look at 11. It says find the 12th term given this equation. So A12 equals -4 times 3 to the n minus 1. So if n is 12, 12 minus 1 is 11. So -4 times 3 to the 11th power. 3 raised to the 11th power, negative 708, 5, negative 708, make sure 588. I hate that I have to go back and forth like that, but that's okay. So negative 708,588 is your 12th term in that sequence. And let's look at our last one. Find the first 4 terms given. The first term is negative 3. Okay, a sub 1 is negative 3. And what is our common ratio? Well, the way they've written this, looks like they put times negative 3. And they put it at the end, but I know just enough to understand they mean multiply by negative 3. So negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. And negative 27 times negative 3 is going to be positive 81. So those are your first 4 terms in your sequence.